up to now, what we have seen is operating vectors using components, using math. So what we have done is we have found the components, we have found the horizontal and vertical components, and then we added them based on the expression that the resultant was. Now, again, a clarification here for everyone, if there is any confusion, this expression will be given to you and it's part of the question. If not, if they are saying that just add them, then you will go a plus b plus d plus c plus whatever vectors you have to add. But if there is an expression, then the expression will be given to you and then you will have it clear and will be part of the question. Now let's see how can we add vectors using graphing. Now, there are two methods that, before we start with the methods, let's see, if we have a vector, then we know now that the vector is represented as a line segment with a starting point and with a tail where it is ending with an arrow at the end. So the vector has a name, and then we know what is the magnitude and what is the direction of this vector. But now if we have two vectors to add, let's suppose we have a vector A and a vector B, that we are just adding those two together. So we will finding the resultant of those two vectors as what is A plus B vector. And in this case, what do we do? Since we don't have those angles, we may measure them, but what we are doing is we are just looking at them from the graphical point of view. How can we add those vectors using graphing? So what do we do is we use two methods. Let's take a look at the first one. So you pick a point on the paper, and then you bring those vectors to this point. So you bring a vector A as you see it there. And then at the same starting point, you bring a vector B. Those two vectors now are used to create the parallelogram, and this is the method is called parallelogram method. So parallelogram is a 2D shape that sides are 2 by 2 parallel and equal to each other. And then the diagonal that start at the same starting point that the two vectors have started will represent the resultant vector, A plus B. So the graphical representation of this resultant is this vector here. This method is known as the parallelogram method. I think that parallelogram method. Why is it like this? Because what you are doing is you are constructing a parallelogram. So sides are 2 by 2 parallel and equal to each other. And then everything in the parallel method starts at the same starting point. The second method, so this is a very used method when we have two vectors to add. But the second method is known as the closed polygon method. The closed polygon method, what we are doing is we are placing the vectors one after the other. So if at the parallelogram method we started everything at the same starting point here, at the closed polygon method we will place the vectors one after the other. So let's suppose that we have two vectors to add. Is vector A that looks like this, and vector B that looks like this. What we do is we pick a point as the starting point, and then we place the first vector, so vector A is here, and then at the end, at the tip of vector A, we place vector B, and then the resultant will close the polygon. This will be A plus B. Understood? You have questions, guys? We will not see this method a lot because we know the more exact method to work with vectors. Do you have any questions? No. What will happen if we have, yeah, will be part of it will be on the quiz, yes. What will happen if we have more than two vectors? So let's suppose that we have vector A, vector B, and vector C. When we are using the first method, the method that we said here, parallelogram method, when we are using the parallelogram method, so what we are doing here is we are finding A plus B plus C. Simple. So when we are using the parallelogram method, we'll take vectors 2 by 2. So we'll start with vector A, bring it here, and then vector B at the same point. It's not that down. Vector B at the same point. We will construct the parallelogram here using those two sides, and then this will be R1, which is A plus B. And then in this, so this will be R1, we will add C now. So we will take that R1, we'll take C at the same point. With those two sides, we will construct the parallelogram, and the resultant will be starting at the same point, going along the diagonal. This will be A plus B plus C. And if you have more than 3, then you will take this and add it to the fourth one, and so on. So the parallelogram method, it's kind of a pain when we have more than 2 vectors. But closed polygon method is very easy when we have more than 2 vectors. because look what we do. So we take the first vector, vector A. At the tip of vector A, we place the second vector, vector B. At the tip of vector B, we place vector C. And then we close the polygon. So we connect the starting point with the end point. And this will be the resultant A plus B plus C. Which method are you using? Doesn't really matter. You can use whatever method you want as long as you are using the right strategy. However, the closed polygon method is easier when you have more than two vectors. When you have just two vectors, either closed polygon method or parallelogram method, they are equally the same. Questions up to this point, guys? So now let's suppose that we have a vector A that goes like this. Now the question will be, what is a 2A? So a 2A is the same as saying A plus A, which means that you are saving direction. So you will have the same direction, but multiplying, adding the magnitude. So A plus A will be something like this. A once, and then A twice. So this one, the whole vector here, is 2A. So this is A, and this is A. Okay. If we have a vector A, B, let's make a vector B now. If we have a vector B that is on this way, what is 1 over 2B? Again, when we have a coefficient, a positive coefficient that is multiplied by the vector, the effect is only on the magnitude, not on the direction, a positive coefficient. So again, we have the same direction, but half of magnitude. Half, because we have this coefficient here. If it was 1/4, then it is 1/4 of the coefficient. What is happening when we have a vector? Let's suppose we have a vector C that is like this. And what we are wondering now is, what is negative 2C? So when the vector is multiplied by a negative coefficient, then we will have the opposite direction and we will have double the magnitude. How can we present it into a graph? Like, how can we represent this? So if this is C, then negative C will be this way. Same magnitude, but opposite direction. And since we have 2C, then we will have twice. So, and then the whole thing here will be negative 2c. But if we have, let's suppose we have a vector d that is like this. And now we are wondering, what is negative 1 over 2, or let's make it 1 over 4 d. So opposite direction. Why? Because we have the negative. We have the negative coefficient here. And the magnitude is 1/4. So if vector d is this one here, then vector 1 over 4d is the same as saying divided it in 4 and will be this one here, negative 1 over 4d. Why do we need to know this? Because we may have to add vectors in the same way as we did with components. So let's suppose now that we have a vector A like this, a vector B like this, and a vector C that goes like this. And what we are doing now is we are finding 2A minus 3B plus 1 over 4, or 1 over 3, let's make it 1 over 3C. So, oops, sorry guys, 1 over 3C. So when we will use the closed polygon one because as we said, it's easier. So 2A will be, if this is 1A, then 2A will be 2 of them. So this is 2A. Now, if B is going east, okay? Now we have negative 3B, which means that we will have negative 1B, negative 2B, and negative 3B. So the whole thing here will be negative 3B. Okay, and now we have 1/3, adding 1/3 of C. So dividing this into 3 parts, and then we will add it here. Oh, let's make it a bit better. We will add this here. So this is 1 over 3C. And what we have for the resultant is starting at the start point and ending at the end point. So this will be the vector. This one is the resultant, that is 2A minus 3B plus 1 over 3C.